Alright, so hopefully you've been able to give this one a try, and if not, remember the whole idea is you're looking for the domain and range of the original function, which in this case is given to you, and you're going to use the mapping rule to determine where your new domain and range are going to wind up. So in this particular case, I'm going to create my mapping rule. Okay, so x within inside the function here, subtract 4, then divide by 3. So in inverse, you're going to multiply by 3, and then add 4. Okay, so that gives you a mapping of 3x plus 4, and then looking at what happens outside to y, it's 2y plus 7. Okay, so now, once you have that, here's where your new domain and range come in. So you know that your original domain goes from negative 12 to 10. Those are your boundaries. You got to figure out where those boundaries are transformed to under the mapping rule. So you have to do this twice. We're going to take negative 12, throw into the mapping rule for x, and see what happens. Then you're going to repeat that process and throw in 10 for x to see what happens. So somewhere down here, make a note, when you put in x equals 12, you get, negative 12, you get 3 times negative 12 plus 4, which is negative 32. And then when you put in 10, you get 3 times 10 plus 4, which is 34. And now then you have to ask yourself, have my signs changed, right? Because now I have negative 32 as one boundary, and I have 34 as my other. So are the signs going to change? Well, did I multiply or divide by negative? The answer is, of course, no, if you look at this mapping rule. So my signs should stay exactly the way they did before. So if negative 32 is less than or equal to x, which is strictly less than 34. Okay, so you get your new domain there. Now, repeat this for y. Okay, same idea, except now you're putting in your boundaries for y. So negative 5 goes into the mapping rule for y, and then 17 goes in the mapping rule for y. Okay, I'll let you do some quick math there, and hopefully you discover that you wind up with negative 3 is less than or equal to y is less than 41. Okay, and again, you'll notice here that there's no change in direction of the signs because, again, you did not multiply or divide by a negative. Okay, so with that in mind, in case you were a little bit stuck, now try and do the second one completely on your own. Give it a try and push play and you're going to go through it together. Okay, so you can take some time to check your answers here. There's your domain, and there's your final range. Okay, so my mapping rule here should be x minus 12 over negative 4 and negative 5y minus 6. So just to repeat what I did before, put negative 12 in here for x. Once that's finished, you put in 10 in here for x. Again, you do this twice. So when you put in x equals negative 12, negative 12 minus 12 is negative 24. Negative 24 divided by negative 4 is positive 6. Pardon me, wrong color. Gives you positive 6. And when you put in x equals 10 in, 10 minus 12 is negative 2, divided by negative 4 gives you positive a half. Okay, now you'll notice here that I divided by a negative, so the signs are switching directions. So I have negative 12 is now greater than or equal to x. So the negative 12, became 6, which is now greater than or equal to x. The 10 became a half, and now that's greater than, x is greater than a half. Okay, so again, the direction of these signs changed because we divided by a negative. So now, just to write this in a more proper way, we tend to write inequalities from smallest to largest. We would write 1 over 2 is less than x, which is less than or equal to 6. Okay, for my range, same idea. I'm going to put in negative 5 into this part of the mapping rule for y, ditto with 17. You'll see I'm multiplying by negative again, so the signs will change direction. So I wind up with, after I do some math, negative 91 is less than or equal to y, which is less than or equal to 19. Okay, so let's keep going, and let's do this with some functions that are, again, a bit more some functions that are transformations of some parent function that we have. So with all of these here, figure out what the parent function is, figure out your mapping rule, and see if you can find your new domain and range. Okay, so in this particular case, looking at the first one for a, my parent function is y equals 1 over x. So that tells me that the domain of my original should be x is not equal to 0, and the range of my original should be y is not equal to 0. Okay, next thing I need is my mapping rule. Be very careful with the mapping rule here. what changes x? It's strictly what's in here in the denominator. See, it's 1 over x in the function, so whatever in the denominator here affects the mapping rule for x. This negative 3, even though it looks like it's in the fraction, and it is, affects the y value, because this function can very easily be written as negative 3 bracket 1 over 5x minus 7 plus 9. Okay, and if it's written that way, it'd be very, very clear to see this negative 3 is multiplying through and affecting the y values, but we wouldn't write it this way because it's simpler to write it in the numerator by multiplying it through. Okay, so for your mapping, what you should wind up with is x plus 7 over 5, and then negative 3y plus 9. Okay, your next step is to substitute the values from the original domain and range into the mapping rule. So let me just clean this up a bit. So your values from the original domain and range are 0 for x and 0 for y. So 0 plus 7 divided by 5 is 7 over 5. So your new domain is x cannot be equal to 7 over 5. Okay, for y, it's negative 3 times 0 plus 9, which is 9. So y is not equal to 9. And there you have it. Okay, with the next one here, again, remind yourself what the parent function is here. The parent function here is y equals 2 to the x, which means your domain and range are, for the domain, x is an element of the real numbers, and for the range, y is greater than 0. So take a minute, try the mapping rule, then try and find your new domain and range. Okay, if you want to check your mapping rule, there it is. Okay, if you're confused about where the x part comes from, remember this is the same thing as 2 to the exponent of negative 7x plus 6. So when you're writing out your input-output diagram here, x gets multiplied by negative 7 before you add 6. So in the inverse, you're going to subtract 6 and then divide by negative 7, which is exactly what you see here in the mapping rule. Okay, so the original function is a domain where x is an element of the real numbers. Nothing will change it. No transformation will change that. So your new domain is still x is an element of the real numbers. Okay, and for your range, you put in 0 into the mapping rule. 0 times negative 5 is 0, minus 8 is negative 8. However, we multiplied by negative, so that's going to change the direction of the sign. So you can see the direction of the sign, instead of being y is greater than 0, is now y is less than negative 8. Okay, you can take a look at the graph here, and just to confirm what the graph looks like. Okay, you see it there. Okay, a couple of other questions here. So same idea here. We're going to look at some transform versions of some parent functions, and we're going to try and find the equation and the domain and range. Alright, so in this particular case here, I'm giving you the transformations. We're going to need to use those to create the mapping rule. So one thing I showed you guys when you're going through the mapping rule is, we're going through transformations, is make a note of yourself which ones are affecting the x coordinates, which ones are affecting the y coordinates, and then of course note the order in which they happen. So here, right 7 affects the x, a horizontal stretch affects the x, a reflection in the x-axis, so reflects it again across the x-axis, would be changing the y. Vertical stretch by factor 3 affects the y, and so does down 14. So now we can apply these transformations in order to get our mapping rule. Squeeze it in there. So I go right 7 first, so I go x plus 7, then a horizontal stretch by a factor of 4, so the multiplication by 4 happens afterwards. As for y, I have a reflection in the x-axis, so I get negative y, vertical stretch by a factor of 3, which multiplies that by 3, and then I go down 14. So in the end, this should be my mapping rule. Okay, so now, to get my transform function here, okay, I can look at my mapping rule for a bit of a start here. So I know that it's a transformation of y equals root x, but outside the function I'm multiplying by negative 3. I'm going to subtract 14. My big concern is what's going to happen inside my square root. So remember, when I'm going from the equation to the mapping rule, I had to take the inverse of what was happening to x. So if I'm going backwards from the mapping rule to the equation or the function, then I still need to do the inverse. So keep in mind here I have x, then the mapping rule I add 7 first, and then multiply by 4. So in the inverse I have to divide by 4 and then subtract 7. So I have x divided by 4 plus 7. Okay, so now, again, let's think about my domain and range of my original function. So my domain is x is greater than or equal to 0. My range is y is greater than or equal to 0. So, just like before, I start using my mapping rule. So, for my domain, put in x equals 0. 0 plus 7 is 7, times 4 is 28. I did not multiply or divide by negative, so my new domain is x is greater than or equal to 28. For my range, negative 3 times 0 is 0, minus 14 is negative 14. However, I multiplied by negative here, so the direction of my sign has changed from greater than or equal to less than or equal to. Okay, we have a couple of examples left. So we have part B here dealing with an absolute value function, and part C dealing with a reciprocal function, and then we're going to have some homework. But I'd like you to try doing B and C on your own first. So this one is nice, it gives you the mapping rule, so try and find your transformed equation and your domain and range. Okay, repeat that process for part C, transformed equation, domain and range, then we'll call it a day. Okay, just let you check your answers here. So where this all come from? So looking at my mapping rule here, which was given to you, the negative 2 and the plus 7, that should be pretty clear. So it happens outside your parent function here, or outside the absolute value of x. As for what happens inside here to x, I look at the inverse. So I have x times negative 3, then plus 5. So in the inverse, I subtract 5 first, and then divide by negative 3. Okay, so then the domain of my parent function is x is an element of the real numbers. So no matter what transformations happen here, that's not going to change. That's going to become my domain of my transform function as well. And for my range, my original range is y is greater than or equal to 0. So if I substitute 0 into this mapping rule for y, negative 2 times 0 plus 7 is positive 7. But you see with this negative here, I've had a reflection, so that will change the direction of the inequality from greater than or equal to less than or equal to. Okay, in the case of y equals 1 over x, my original domain, x cannot be 0. My original range is y cannot be 0. For a transformed equation, I have y equals 5 times something with 1 over x, but it's going to be not 1 over x, it's going to be 1 over something else. I'm going to have minus 8 out here. Okay, for the inverse here, it's x minus 4, then divided by 7. So I'm going to have x times 7 in the inverse, and then plus 4. Okay, realistically though, you'll never see it written like this, so you should simplify this, or else you risk being charged communication. Multiply the 5 into the numerator where it should go, and you wind up with y equals 5 over, y equals 5 over 7x plus 4 minus 8. Okay, so put your original domain and range into the mapping rule. So sub 0 in here, 0 minus 4 over 7 gives you negative 4 over 7. Okay, and then you put in 0 in here for y. 0 times 5 is 0, minus 8 is minus 8. So x cannot be equal to negative 4 over 7 is your domain, and y cannot be equal to negative 8 is your range. Alright, so that's it. I've given you guys a worksheet that sort of has a lot of these types of problems and brings in a lot of the stuff from the unit all together, so it makes really, really good practice for your upcoming quizzes and tests. Alright, that's it, that's all.